Hello, everyone, and welcome to 12-2 Conditional Probability. So, we're still learning about how probability works, how to determine what the whole group I'm picking from is, and that's going to be really important today in conditional probability. So, today I want to be able to find the probability of an event given that I know something else has happened, given that another event has occurred. So, we're going to start with a warm up. You're going to try it out, pause the video. When you have what you think is the answer, we'll discuss it. Okay, so at Central High School, 85% of all senior girls attended and 65% of all senior boys attended the spring dance. And of all the attendees, 20% won a prize. Now, this next line is really important. Assuming that the number of girls is equal to the number of boys, let's estimate the probability that a randomly selected senior won a prize. Now, when I see a problem like this, and they don't tell me the numbers, they just tell me percents, I like to always assume that there's 100 people. So in this case, I'm going to assume that there's 100 girls and 100 boys, because they said there's an about equal amount of people in the class, and 100 makes my calculations really nice. So 85 out of the girls attended, and 65 of the boys attended. So what that means is 150 people attended, and then the problem also tells me that 20% won a prize. So 20% of 150 is 30 students. Now it's asking me what's the probability that a senior won a prize, so I need to know 30 out of my 200 students won a prize, and 30 out of 200 is 15% or 0.15. Now we can take this a separate approach and just use all percents, but I really prefer setting it up and looking at it as actual numbers, where instead of saying just 85% of a random number, I like to say that we start with 100 people. You could start with 200 people or 1,000 people, and either way, the percents will still remain the same. So this is an example of conditional probability. We're going to assume that they went to the dance and that they won a prize. So once again, we have some vocabulary. You can pause the video and copy it down. Conditional probability, which we talked about, that's our lesson target. And then dependent events, which we talked about in 12-1. So there are events that are affected by previous events. So let's explore a little bit. We have a frequency table, which is a table counting how many people did what. So here we have 3 sophomores in drama. We have 17 total people in drama. Okay, 115 people total. So the frequency table shows the membership of 3 clubs in the high school: the drama, the science, and the art clubs. All pretty good clubs, if you ask me. A student committee is being formed from members of these clubs to determine how funding will be allocated for the next year. And they're going to want to use some probability data to allocate the funds. So what's the probability that the first student selected is a junior, and what's the probability that the first student selected is in the art club? So go ahead, pause the video, see if you can come up with the probabilities, and then check your answers with me. So first, we're going to look at the probability that the first student selected is a junior. So what I see here is there's 40 total juniors out of 115 total people. That's my probability. So my probability of junior is 40 out of 115. I can simplify, I can write it as a decimal if the problem asks me to, but I like to always start in a fraction. Now, what's the probability that the first student selected is in the art club? We're going to do the same thing. How many students are in the art club out of how many total? So what our total is really an important number because that's going to be our denominator. So we have 58 students in the art club out of 115 students total. Okay, simplify if you'd like to. Maybe it doesn't simplify. Sometimes, especially on Pearson or other programs, it's going to want a decimal. So always read the directions. Now, we got 3 more questions. And these are going to go a little bit more in depth and really introduce us to conditional probability. So what is the probability that the first student selected is a member of the drama team, given that we know the student's a sophomore? What's the probability that the first student selected is a sophomore, given that they're a member of the drama club? So we know that they're a member of the drama club. What's the probability that they're a sophomore? And then we're going to compare those two probabilities, because those two sentences say very similar things, but we need to see if the order is going to affect the probability or if the probability remains the same no matter the order. So pause the video, try to think of what these questions are asking and how to calculate these probabilities, and when you're ready, unpause the video. So let's look at this first question. What's the probability that the first student is selected is a member of the drama club, given that they're a sophomore? So we know that we're only looking at the sophomores. So we're only looking at 36 total people here. And we want to know how many sophomores are in the drama club. So we have 3 sophomores in the drama club out of 36. So the probability of drama club given sophomore, and we're going to see what this symbol means momentarily, the probability is 3 out of 36. Because 3 out of the 36, because we already know they're a sophomore. Now the second question says that they're a member of the drama club. So we have 17 students that are in the drama club, and we want to know how many sophomores are in the drama club. So this is 3 out of 17, because with this one we know the group is all the students in the drama club, whereas the last one, it was out of all sophomores. So the order is going to matter. Okay, we're picking from different groups. If we know that the student is a sophomore, we have 36 students to choose from. Well, if we only know that the student's in the drama club, we have 17 students to choose from. Now, this is an example of conditional probability. What conditional probability is, it's the probability that an event B will occur, given that we know that A has already occurred. So in that first problem, we can go back and look at it. This first one, we knew that they were a sophomore. So what's the probability that they're in drama club given that they are a sophomore? And this symbol means given. Okay, so the probability of B given A, here's a formula for it, and we'll analyze and see how this formula works, is what's the probability that they're in A and B over the probability that they're in A. So the last example, we didn't use probabilities, we used raw numbers. So we looked at how many students were in drama and sophomores over how many sophomores. Now, conditional probability relates to independent events, and we could check whether events are independent. So if the events are independent, the probability of A given B is the probability of A. So what this is saying is that B does not affect the likelihood of A. So the probability of A given B is the same just as the probability of A, because B should have no effect, because that's what independents do. They don't interact with each other or change the outcomes. And we also have to check the reverse, that A is not going to affect B. So the probability of B given A equals probability of B. So we can check for independence to see, does an event affect another event? And we're going to test it out. And this is a challenge problem. So I'm expecting this problem to be hard, but I'm expecting you to try it as well. So a band's marketing agent conducted a survey to determine how many high school fans the band has. What is the probability that a surveyed student, so a random student, plans to attend the band's concert and is a fan of the group? So pause the video, write down as much information as you can, try to answer this question, and we'll discuss the answer. Okay, so now that you've unpaused the video, let's look at a few of the details. So I see the first thing, we're going to define our variables. So we have 2 different events happening. We have either plans to attend or doesn't plan to attend, and are they a fan of the band? So I'm going to write down a few of my data points. Okay, the probability that they are going to attend, 70% attend, 30% do not attend. Now remember, this is the complement symbol, so I want to say probability of not A is 30%. Now we got to get into more of the details. So it says, given the students that attend, so 80% are fans given that they attend. So out of the ones that attend, 80% are fans of the band. And this bottom says, given that they don't attend, 25% are fans. So now we have all of these numbers in mathematical language, which is very hard to do and it takes lots of practice. Now, what we are trying to find here is what's the probability that a student plans to attend and is a fan. And we could write this backwards. We could say what's the probability that they're a fan and plan to attend. So we need to write a conditional probability formula. And we need some pieces in our equation. So if we're looking for a probability that they're fan and they're attending, we also need to know the probability that they're just attending and the probability that they're a fan given that they're attending. And we have that information above. We just got to be careful how we put it into the formula. So we know that the probability that they're a fan given they're attending is 0.8. We know that the probability that any random student is attending is 0.7. And we can call this here x. We can call our variable x, and we're solving for x. You can leave it as probability of fan and attending, or you can write it as x if you want to simplify your calculations. So I might have 0.8 equals x divided by 0.7. And we need to know how to solve. So probability does have some algebra in it where we have to solve. So what we're going to do is we're going to multiply both sides by 0.7 to get rid of the denominator, which I did here. And let's get the probability that they're a fan and they're attending is 56.56, which is 56%. So given a random student, okay, out of all of these students, there's a 56% chance that they're a fan and they're going to attend. And we can calculate that using the conditional probability formula. So this is the intro to conditional probability. Please check and watch day 2 video when you're ready. And there will be more about conditional probability.